Hello everyone, and welcome to the uh, continuation on our solution to the 2025 West African Senior School Certificate Examination. In previous videos, we've considered the first three questions. Now we are going to consider the fourth one, which is a question on elevation and depression. Now we have this diagram here, and we are told that the diagram shows a tower TR and an observer O. So here is the tower TR. Here is the tower, and this point is point O, where we have an observer. OR is 84 meter. So this is telling us what we have been given here. So this is point O. So OR is 84 meter, and the angle of elevation of the top of the tower is 57. So the angle is not shown in the diagram originally given in the question. We have been given the angle of elevation of the top. So here is the tower. So this is the foot of the tower, while this is the top of the tower. And here is someone observing the top of the tower. So here is the observer looking at the top. So you've been told that the angle of elevation of this top from the observer here is 57 degrees. So you have to calculate correct to three significance figures. So this is significance figures. The height of the tower. So you have to calculate TR basically. That's the height of the tower. Then we are told that the observer at O moved away from the tower. Yeah, initially the observer was here, then he moved away from the tower in the same straight line until the angle of elevation of T is 49. You have to find correct to two decimal places. So I just shortened this. This is decimal places. How far the observer moved backward. So let's not waste time. Let's consider how we'll solve this. I'm going to be drawing the diagram again. This was given in the question. So let's have the diagram again for the first part of the question. That's question A. So we'll have the diagram. Here's the tower and the line joining the top of the tower and the observer. So we have this. So here is the top of the tower. Here is the foot of the tower, which is labeled as R. And here is the observer, O. So you've been given that OR is 84 meter. So that was given in the question, in the diagram in the question, and it was still given here. So OR is 84 meter. Then so what we're not given in the diagram here, the angle of elevation of the top is 57 degrees. So in case you have forgotten, if you have an observer here looking at something higher than him here, so the angle of elevation is the angle between the normal eyesight of that observer if he was not looking up. So if this observer as O were to be looking straight, he's supposed to be looking at up here. But by the time he raises his head up to look at the top T, so the angle between the normal eyesight and when he raises his head up, this angle is going to be the angle of elevation, which was given in the question to be 57 degrees. So here is 57 degrees. So then the first question is that we should find the correct to three significant figures, the height of the tower. So remember I told you this is the tower, TR. So you have to find the height of the tower, you have to find TR. So I can decide to be writing TR. Okay, let's just continue that way. So you have to find TR basically, that's the height of the tower. Now, you've been told in the question that this angle here is 90 degrees. So this is 90 degrees. And that will give us the license to use our SOHCAHTOA to solve this problem. So as a form of reminder, use SOHCAHTOA, that's your sin theta equals to opposite over hypotenuse and others. And the Pythagoras theorem, use those two to solve only right angle triangles. And what are right angle triangles? They are triangles that have one of the three angles to be 90 degrees, as you can see here. So the moment you have been told this is 90 degrees, then we can use either Pythagoras theorem or SOHCAHTOA for this question, as the case may imply. But here we cannot use Pythagoras because we only know a side and an angle. So we can use this to use any of the basic trigonometric ratios, sine, cosine, or tangent, anyone applicable. Now to this angle 57 here, this TR is the opposite. The side facing the angle is the opposite. So TR is opposite to 57. So meaning what we want to find is the opposite. Now the longest side, that is the side facing 90 degrees, is always the hypotenuse. And it's always the longest. So we have no business with the hypotenuse for now. We were given RO, that's adjacent. So when you have the right angle triangle, you can always locate your hypotenuse and your opposite first. Then automatically the third side becomes the adjacent. So since we have established that the side facing 57 is the opposite, and the one facing 90 degrees, that's this 90 degrees, the one facing it is the hypotenuse, then automatically this 84, that's RO, is going to be the adjacent. So it means we want to find the opposites while we know the adjacent. So of the three trigonometric ratios, your SOHCAHTOA, the one that combines opposite and adjacent is TOA. That's tan theta equals to opposite over adjacent. So we make use of that. So you have that tan theta is going to be equals to opposite over adjacent. So our theta here is going to be 57 degrees. So you have tan 57 degrees equals to opposite. That's, I mentioned it earlier, that's TR. That's the tower, the height of the tower. So TR over adjacent is 84 meter. So using your calculator, tan 57 is going to give I think 1.5399 from what I have here. 1.5399 equals to TR over 84. So to find TR, we just cross multiply. You know this is over 1. So cross multiplying TR times 1 is going to give TR equals to this times this, 84 multiplied by 1.5399, and that's going to give you TR to be. So when you press 84 times 1.5399 on your calculator, that should give you 129.3516. So this is the answer written to 4 decimal places. So that is the default way you are supposed to write the answer. Then we can now go to the approximation. So if in the question you were not told to approximate, you can decide to give it, just put the units meter. So this is meter. However, in the question we were told to approximate to 3 significant figures, which you must take note of. So if you should leave your answer this way, the marking guide will be instructed not to give you the. In fact, if you approximate wrongly, you are not going to be given the answer mark. You get a mark for anyone that has a mark here, but not the answer mark if you not approximate. So you must not stop here. So this is going to be approximately equals to, so to 3 significant figures as we have been instructed in the question. So significant figures basically are non-zero numbers. Though zero can be significant in some cases. Perhaps there's going to be another video for approximations. So this is the first significant figure here, the second, and the third. So you have the first 3, 1, 2, 3. All we have to do is to consider the one that follows, which is the fourth. Is it up to 5? If it is up to 5, you round it up to 1 and add it to this 9. But since what follows 9 is not up to 5, so we round everything off. All these ones become 0. So to 3 significant figures, this is going to be 129 meters. So that is our answer to 3 significant figures, and with that we've solved the first question. Then for the second one, it said the observer at O, remember this is the observer, moved away from the tower in the same straight line until the angle of elevation of T is 49 degrees. Now what we are seeing here is, so we might still have to draw another diagram here. So this observer, okay, this is this was the original diagram we had. So we had this. Sorry for my line is not that straight. Okay, so you have the top of the tower, the R, the base R, and this was the original position of the observer, which was said to be 84 meters from R. Now they said the observer then moved away from the tower. Look at it, moved away, not towards. Remember this is the tower, so he moved away from here on this same straight line. So he moved this way. So the observer was here. Now he has moved to this point. Let's say this is where he is now, away from the tower. So if he was said to move towards the tower, I would have said he moved towards it. Well, the question says he moved away from the tower. So let's assume this is the new position of the observer. So say we'll call this position perhaps N, and call it anything you like. So they said after he has moved away a certain distance from the tower, on the angle of elevation of T is now 49 degrees. So the angle of elevation of this top, when he was there, it was 57 from the initial question. Now that he moved away, the angle of elevation of the top is now 49 degrees. So it means the angle of elevation of from here to this top is now 49 degrees. So after he has moved to this point N, the angle of elevation of this same top again is now 49 degrees. So this is the new angle of elevation degrees. So you are still talking about this top. However, it's no longer here. It's now at this new point. So the distance at which he moved away were not stood. So he was here, he moved to this point. And that is the distance they ask us to find. How far, we have to find correct to 3 decimal places, how far the observer moved backward. So he was here, he moved there. We want to know how far he moved. We want to know ON. So this time I will prefer to call this ON. I'll call it X. So X is the distance with which he moved backward, and that is what we want to find. Now, how do we find it? Now, from what we have here now, Rn, we can know Rn. This Rn, that's the distance from R to N, can be found. Remember, R to O is 84. Then O to N is X. So the total distance here is going to be 84 plus X. So we're going to have this to be 84 plus X. And remember, we have found the height of the tower to be approximately 129, though I'm not going to be using the approximative value. So I'm going to be using this, because there are times that using approximative values might make your final answer to vary significantly from the answer in the marking guide. So it is always preferable whenever you want to use a particular answer in a new calculation, you use the one you wrote to at least 4 decimal places. In some cases, the difference might not be significant, but in other cases, it might be. So we're now considering this diagram now. So to find X, what we are going to be considering is, remember this angle is 90 degrees. And we have like 3 triangles here. We have triangle TRO, we have TON, then we have TRN. These are the 3 triangles we have here. And of the 3, only 2 is right angle triangle, and that is TRO, which you use in solving the first question here. Then TRN is also a right angle triangle. It's also a right angle triangle because angle R, the two of them has angle R. The two of them have angle R, and angle R is 90 degrees. So it means for triangle TRN, in that triangle, just assume this line is not there. So assume you are looking at a triangle TRN without this line. So and you see that that is a right angle triangle too, with size 129.3516, side 84 plus X, and side TN. Again, we have no business with TN. So all we need to do now is to use any of the ratios again for this side and this side. And this time again, you are still going to be a case of tan, because to this 49 degrees, 129.3516 is T and opposites, and 84 plus X is T and adjacent. So you are still going to use tan. Theta now is now going to be 49 because we are considering, so I should have written that first. So I should have said in triangle TRN. So to show that I'm referring to triangle TRN. In triangle TRN, and theta, which is 49, equals to opposites, which is 129.3516, 129.3516 over adjacent, which is this entire length. That's 84 plus X. So we'll continue from here. Let's just try to proceed here. So tan 49 is going to give us 1.1504 from calculator. So 1.1504 equals to, we have 129.3516, 129.3516 over 84 plus X. 84 plus X. Now from here, what we'll do again is to cross multiply. So this times this is going to give us 1.1504 times 84 plus X. 84 plus X equals to then 129.3516, 129.3516 multiplied by 1 times 1. So opening this bracket here, 1.1504 times 84 Using your calculator will give you 96.6336. Then plus this times x is going to give us 1.1504x equals to, and multiplying this by 1 will still give you the same number, 129.3516. Now we have to do is to find x. And what do we do next? We'll collect like terms. So this can come to the side. So we are going to have 1.1504x equals to 129.3516 minus 96.6336. And computing that subtraction, you're going to have 32.718. Then make x the subject. X is going to be equals to 32.718 divided by 1.1504, and x is going to be 28.4405 meters from the answer I have on my calculator. So I have x, which is the distance ON. That's how far the observer moved backward. So x is now what? 28.4405. It means the observer moved backward by this distance. But don't forget, we still have an approximation. Find correct what? 2 decimal places. 2 decimal places means 2 numbers after decimal. So in that case, we have no business with the numbers that come before decimal. We are only considering the ones after decimal. So count 2 numbers, 1, 2. Then after counting 2, you only consider the third one, the one that follows the number you need. We already counted 2. This is 0, not even close to 5. So you neglect everything that follows. So this is going to be approximately equals to 28.44 meters. And that shows that the observer moved backward from his initial position O to a new position N by a distance of 28.44 meters. And that is all you are required to do in the question. So I'm going to see you in the next question by God's grace. Thank you very much for listening.